Hey there, and welcome. Today, we're taking a trip to the dark side of the universe, hunting for the ultimate cosmic monsters. We are going to dive deep into one of the most powerful, most destructive, and, believe it or not, most creative forces in the entire cosmos, the black hole.
And you know what? For the next few minutes, we're taking that invitation seriously. We're going on a virtual voyage right to the edge of what we know, to really understand what these incredibly mysterious objects are. So let's get started.
So here's our game plan for the journey. First, we'll figure out what these cosmic monsters even are. Then we'll get into the mind-bending theory that predicted them. After that, we'll travel to their violent birth and their infamous edge, learn how we actually find these things, and then we're going to take the plunge inside. All right, first things first. Before we go hunting for these cosmic beasts, we really need to know what we're looking for. I mean, what is a black hole really? Well, the simplest definition is probably this one. A black hole is basically a place in space where gravity is so incredibly strong that nothing can get out. And I mean nothing. Not a planet, not a spaceship, not even a beam of light. It is the universe's ultimate one-way street. To really get your head around this, try to imagine that the universe isn't just empty space, but more like a giant flexible sheet of fabric. A black hole isn't just some object sitting on that fabric. It's a place where that fabric has been stretched down so deep, it's created a well that is literally impossible to climb out of. So a puncture in space-time, I mean, that sounds like something straight out of science fiction, right? Where did an idea this wild even come from? Well, for that, we have to thank the one and only genius who completely rewrote our understanding of gravity itself. You see, before Einstein, everyone just thought of gravity as this invisible force that pulls things together. But what Einstein realized with his theory of general relativity was way more profound. He said that massive things like our sun don't really pull the Earth. They actually bend and warp the fabric of space-time around them. And what we feel as gravity is just us rolling along those curves.
And this idea has been kicking around for longer than you'd probably guess. It actually started as a wild thought experiment way back in the 1700s with these things called dark stars. But it was Einstein's math in 1915 that made it a real possibility. For decades, most scientists thought it was just a weird quirk in the equations, until the 1960s, when they proved that nope, black holes were a natural result of his theory. And then in 2019, it happened. We actually saw one.
Okay, so we've got the theory, but how do you actually make one of these punctures in space-time? Well, it turns out the recipe calls for one of the most violent and spectacular events in the entire universe. It all starts with the death of a truly enormous star. We're talking something at least 25 times bigger than our sun. For millions of years, that star is in a constant battle. The nuclear fusion in its core pushes outwards, while its massive gravity tries to crush it inwards. But eventually, the star makes an iron core. And you can't fuse iron to get energy. The furnace goes out. There's no more outward push. In that instant, gravity wins, and it wins big. The core collapses in on itself, and while the outer layers get blasted into space in a supernova, that core just keeps on collapsing and collapsing until it becomes a black hole. And that insane collapse creates the most famous part of a black hole, the event horizon. Here's a way to think about it. Imagine you're in a boat on a river that's flowing towards a giant waterfall. For a while, you can paddle and get away, but eventually you'll cross a point where the current is just too strong. No matter how hard you paddle, you're going over the edge. That's the event horizon. Once you cross it, every single path leads in one direction, inwards. There is absolutely no way back. But here's the thing, not all black holes are created equal. Those ones born from stars, we call them stellar mass black holes. But then you have the supermassive black holes. These are the true giants, weighing millions or even billions of times more than our sun. And we think there's one at the center of pretty much every galaxy, including ours. How they got so enormous is one of the biggest puzzles in astronomy, but it definitely involves a lot of eating stars and crashing into other black holes. So this brings us to a huge problem. If black holes are, by definition, black, and they don't let any light escape, how in the world do we find them? How can you possibly see something that's totally and completely invisible? Well, the trick is, you don't look for the black hole itself. You look for the absolute chaos it creates all around it. We see the telltale signs everywhere. We can watch stars whipping around a point in space where there appears to be
Nothing. We can see superheated gas glowing in X-rays as it spirals in like water down a drain. And, maybe most incredibly of all, we can actually detect the ripples in spacetime, gravitational waves that get sent out across the universe when two black holes smash into each other. And these methods, they work. That very first picture of a black hole, the one in the galaxy M87, we figured out it has a mass of 4 billion suns. I mean, just try to let that number sink in. And you don't even have to look that far away. The beast that lives in the heart of our very own Milky Way galaxy, Sagittarius A star, it clocks in at a cool 4.3 million times the mass of our sun. Which, of course, leads to the one question everybody wants to know. We've journeyed to the edge. We've seen the chaos outside. But what would happen if we took that final step? What if we actually fell past the event horizon? Okay, let's do it. Let's cross the point of no return. What's waiting for us inside a black hole, at the very heart of that puncture in space-time? This is where our journey leaves what we can see behind and enters the truly bizarre world of theoretical physics. According to Einstein's theory, all the stuff that's ever fallen into the black hole, entire stars, gas clouds, planets, you name it, gets crushed down to a single point with zero size and infinite density. This is what we call the singularity. It's a place where our laws of physics, our understanding of reality, just break. Now, science fiction absolutely loves the idea that the singularity could be a secret doorway, right? A wormhole to another time or another universe. But the scientific reality is, well, it's a lot more grim. As you get closer to the singularity, the pull of gravity on your feet would be so much stronger than on your head that you'd be stretched apart like a piece of spaghetti. It's a process with the fantastic name spaghettification, and it means total destruction, not a quick getaway. But here's the final and maybe most mind-bending twist in the whole story. These engines of complete and utter destruction are also, weirdly, engines of creation. The powerful jets and winds that blast out from around a black hole don't just throw out energy. They spread heavy elements forged inside stars, things like carbon, oxygen, and iron, all across the galaxy. They're actually seeding the cosmos with the raw materials needed for new stars, new planets, and maybe even for life. And that kind of leaves us with this final amazing thought to chew on. We started this journey hunting for a monster, but we found something so much more complicated, a cosmic force that tears things apart and builds things up at the same time. It really makes you wonder, if these objects helped build our galaxy, what other fundamental secrets about our universe, and maybe even our own existence, are they still hiding out there in the dark?